Thank you for the presentation. As we got into the introduction, it's cloudy with a chain of exposures. After I did this research and see the state of the cloud, I think I would like to change it to cloudy with a chains of big exposures. And you will see why. So firstly, who am I? Nenad, Zaric, CEO and co-founder of Trickest. Previously, I was a bug bounty hunter, found critical vulnerabilities in Uber, Twitter, Snapchat, and other companies. And I also did penetration testing and security engineering before that. So we can start with what is the cloud. I extracted the definitions of the cloud from official cloud providers, and these will be cloud providers that we will do exposure scan on. So it's on-demand delivery of IT resources or computing services, servers, and so forth. So the cloud is actually somebody else's computer. And you need to keep that in mind always when you think about the security, because it's just somebody else's hardware and the infrastructure, which is kind of the same as your own personal computers. So do you think the cloud is secure? These are the definitions of these cloud providers. So they say it is architected to be the most secure cloud infrastructure. The risks are relatively low, and they are fine, as it looks like from their definitions. But I was suspicious, as you can see on the down right side. So hackers don't believe this kind of definitions. These are the screenshots of the exposures. We will go through this presentation. So let's start. Firstly, we need to get all of the IP ranges from these cloud providers. So this is like a simple script which is getting AWS's IP ranges by using curl and JQ. It's a simple one. And we get all of the AWS's IP ranges in there. The next step is GCP one. Again, curl and JQ, and we got GCP's IP ranges. Azure is a bit more complex, so we get a URL, we download it, we extract the JSON, and then get all of the IP ranges. And finally, DigitalOcean, we download CSV file. DigitalOcean apparently uses Google's IP ranges, so we just get them and again create an IP range list. So I used actually Trickest for it, so this is how it looks like visually. So all of these scripts are basically the scripts that you saw before, executed in a container, and then get all ranges is a script which merges all of them together. The next up, we have like a map CDR, which is a tool which does slicing of those IP ranges. So I wanted to create something like standardized in order to distribute all of the scans. On the left side, you can see which was the actual command that is being used. So now we come to the port scanning. We got all of the IP ranges, and we want to find all of the open services. So I did a bit of research, checked how these tools behave when you execute it on this large scale. There were actually more than 160 million IP addresses that needs to be checked, times ports, so it's a lot of tasks and a lot of distribution. So Nmap turned to be slow, you probably know that. RASScan is fast but inaccurate. Every other execution turned out to have different results, so I could not rely on it. Nabu was okay, it had a good results, but also it was slow. And MassScan is extremely fast, but if you compare the accuracy and consistency of the results, again, it's kind of similar to RASScan, maybe even worse. So I chose one, and it's a ZMap. It's a fast single packet network scanner. It's available on GitHub, so you can use it, like download it and install it and use it. And this is the command. The thing that is like problem with ZMap is that you cannot add all of the ports. You need to have separate commands for each of the IP range and a separate port command. So this is how the final workflows look like. And on the left, you can see all of the web ports I have checked. In the middle is the Trickest workflow editor with all of the ZMaps on all of those ports. And you have at the beginning IP ranges, map seeder, distribution, ZMap for the ports, merging them all together. And on the right, you can see how like the final result looks like. It's like IP ports TXT file, where you can see all of the IPs and ports combinations that are being found. So now we turn to the web. So we want to get web servers data. So we use a tool called HTTPX, where we executed it again distributively on all of those IPs and ports that we previously found. And now we want to consume the data. So we decided that we can go to Elasticsearch as like a full text search database in order to ingest all of these millions of IPs and metadata and web service data to be able to query it on each of the data that it is in there. But there was no tool where we can do this to easily extract the data from HTTPX and then import the data into the Elasticsearch. So we created one, and actually this tool is public as of yesterday night. So you can just check it out and use it for your own purposes. It's open source. It's a kind of simple Python script, command line Python script, which you can use and ingest any kinds of like security, attack surface management data into the Elasticsearch. And it has the capabilities of deduplicating the data, pretty fast importing, and yeah, you can use it the way you want. This is the actual command, so it gets a file. The field command is a URL, something that we don't want to have duplicates for. And config file is actually credentials to the Elasticsearch instance. This is how this data actually looks like in the Elasticsearch database. So on the left are all of the fields which we could filter, and we can enable them and see them in a kind of dashboard, and of course we can create additional visualizations. Now the fun stuff. The exposures. This is the way how to query. So you enter just a key and the value for a key, and you would get all of the results. All of the IPs and ports and web services which have this title or any kind of other key inside. So the first that catched my mind, my mind is a directory listing, which have a lot of hits, nearly 42,000, and this means that it just prints out all of the files and folders in a web server directory, and all of these requests are sent to the root path. So we didn't did any brute forcing inside. It's just a simple request to the root path. And I actually found like corporate and government documents inside, IDs, passport, source code, executables, logs, CI/CD configuration files, and a lot more. So anyone that like, it kind of looks like somebody's desktop when you see these directory listings. And on the left, you can see what are the queries to execute to find these sorts of data. The next is whoops. I saw whoops a lot, and I was like, what is this? And it's actually when the debug mode in Laravel is enabled. And when you send a request to the IP and port, it could happen that it leaks environment variables. So here, I saw like AWS access and secret keys. You can see down there, session cookies, DB passwords, connections, URLs, all sorts of stuff you can imagine. So search for whoops. For Django, I found two types of like exposures. It's API endpoints. It could happen when there is no root at the Django on the root path. It just leaks what are the API endpoints with the debug enabled. That's of course for the developers to understand what the roots are available, but for hackers it's something that they take advantage of. The title for the query for this is page not found at like / at a root of the web server. Also, there is like allowed host variable in Django, so it allows Django to be opened from a certain host name, But if no IP is in those allowed hosts and the debug mode is enabled, then it again, like Laravel, leaks out the environment variables. And again, it's like secret keys, access keys, and a lot of endpoints. For Swagger, it's also a common case with 5,000, nearly 6,000 hits. So open full API documentation, which you can execute, and I actually saw a lot of them without authentication. So it looks like developers create APIs and kind of create their architecture of API without thinking about the actual authentication. So you can just go to the API endpoint, click try, then you would execute a request and get, in this case, all of the accounts of this API endpoint. So let's see what other HTTP titles are there. So this is the list of like the most frequent ones. There are a lot of them. So when I started doing this presentation, like I always took like an additional 2 hours to go through it, and then I went into the rabbit hole of digging into this data and what is happening inside. So I needed to focus, so I created this kind of, for me to be able to see what is interesting. And Grafana is interesting. So we found Grafana dashboards, unauthenticated ones, and it looks like in some of the cases they presented the metrics for even power plants and like for car charging station, electric car charging stations. A lot of data around like different APIs and logs around web services. And as I understood, and I'm not completely 100% sure, but people think that using Cloudflare and this kind of like firewalls could prevent them to have a direct IP access to these sorts of dashboards and software. So it's not the case. Actually, when you do it in reverse, when you scan IP and you get SSL certificate and you end up in this dashboard, you can actually understand which company is using this kind of software without an authentication. PHP info is the second one. And like when developers do, when they set up a server, they create a PHP info file to see everything is right. It also could leak a lot of secrets and credentials and a lot of configuration about that specific environment. And now we can turn to actual scans. So before it was only getting the web services data, nothing additional in terms of the scanning. So we'll do now like a full scan. So for exposure scan, we use Nuclei, also inside of the platform. So on all of the web services, we use Nuclei for with the exposure tags and with additional ones. So there was a Symfony debug, which leaked, like in this case, database credentials, but there was a lot more of the events, routing, and like it was like an admin dashboard for the whole Symfony framework. OpenAPI specifications, so we sent the request to openapi.json, and we got the JSON. So it's kind of like Swagger API or endpoints from Django. So it leaks all of the data around the specific APIs. There are, like, as you can see, a lot of hits, 37,000. Open AWS buckets, they are kind of the same as directory listing, but the data is stored on S3 storage. I also saw a lot of configs, especially for the mobile apps. I don't know why it's the case that they forget to like restrict the mobile developers forget to restrict the data on the buckets, but that's what I found. Unauthenticated Jenkins dashboard. Basically, again, the host was not resolvable from the outside, but it was resolvable with a direct IP access. And actually, I found Open Jenkins dashboard with credentials for one company which have more than 2,000 employees, with credentials inside of their database, their personal emails, their whole team. So I kind of got all of their team inside of an email and then send them they need to fix this as soon as possible. Redis Commander is just like a dashboard for Redis database, and here I found like Those were just random findings, but I found like telephone numbers and SMSs that are being sent to different users as a part of the web application. GraphQL Playground, like it was available with like, you have everything. You have even beautifying of the code to send the GraphQL queries. And what I saw is that when you find this development, this kind of application, then you can also do an introspection query and get the whole database schema of a GraphQL database. Because like if they leaked out this kind of playground, then they probably didn't they didn't fix the introspection to be disabled. And now, like a bit more fun stuff, Kubernetes APIs leaked, and this is actually, when you find this, it is possible to also do remote code execution on the cluster. So when the API is open, you can just execute, you can spin up a new container and execute remote code execution inside of that cluster. And I don't know if you can see it, but this is actually government's Kubernetes cluster. I know which government, but they stopped when I saw it. So like, everybody could do this kind of exposures, especially on Kubernetes, since it's a complex system. So we must take care of it also. Now we switch to the actual credentials. These are the credentials that are being found. And again, we only requested the path. We didn't do extraction of JavaScript, getting to the endpoints, just the root path. So the Google Client ID, nearly 6,000. Artifactory API key, which is like repository manager for software packages, 272 hits, which basically means you can download the source code of a company if you find this. Stripe secret key, you probably know what you can do with Stripe secret key. Get all of the payments on your own bank account. And like, that's something that's like more into the like fintech side of the things, where like people just leak these kind of credentials away for everyone to see. Zapier webhook tokens, so you can send hooks to Zapier automation, so you can also impact the business side of a certain company that leaked this. Of course, open API keys. I actually found that a lot of them are valid, and like you can extract and you can use them for your own, AI trainings, LLM trainings through OpenAI's APIs, which of course should be also deleted. And additionally, OpenAI has a bug bounty program where you can find these leaks, you can submit to them even though that's not their fault. And what about environment files? I kind of regretted doing this for some reason. In like 1 minute, I got around 60 abuse requests from AWS when I sent the request to /env. And I don't know really why it is the case, but it seems that like people are really worried about .env files, because when I did it with the other parts, it was fine. I didn't get any abuse request. And actually what happened, it's a funny story, that when I got this abuse request, I sent an email to our AWS account manager to explain that I'm not doing anything too intrusive. I just sent a request which everybody could send from a browser, and we got on a call. I showed them one of those emails, and I copied the URL in new tab in order to like explain that this is just a random request anybody can do. And actually this send file leaked access keys and secret keys of their AWS account. So companies would rather send abuse requests to AWS, to us, instead of like just removing the environment file in their infrastructure. So that left me thinking that why don't we take offensive security more seriously? And thank you very much.
So I have a question regarding if you tried to run the same flow on a database with malware IPs, and what are the results for?
Yeah, we got like a lot of the IPs with which were honeypots basically. Like so they
do you have a tool to recognize honeypots?
it was just a script which recognized if there is like more ports than it should be, like more than 15 ports, then we consider it as a honeypot.
Okay, and the first question was, if you tried to run the same flow, not on AWS IPs, but to take a database with malware IPs and to run the same flow on
It will work. It will just work.
Yeah. If you tried it, did you try it?
I didn't try it, but I could. Thank you for that.
Thank you for the presentation. As I saw, there are a lot of manual steps you have explained. How can you automate this in order to have continuous monitoring?
That's what Trickest platform is all about. So this is like actual automation of workflow which is like doing a distributed execution on like 50 to 60. I use 50 to 60 instances for this research. So it's actually there. You can just use it.
Thank you.
While digging through all the data that you found that was unauthenticated, and you found the classic stuff, to put it like that, credentials, API keys, debug options. Aside from that, what was something that you found that struck you like that really shouldn't be out in the open? It was weird. It was.
Yeah, you meant the most critical thing that I think should not be there. A lot of them are really critical, to be honest, because like if you have debug mode, you can like get AWS secret and access keys for the whole environment. So it's it depends on an actual case. But maybe I would say Jenkins leaked the most stuff around the leakages itself. So it leaked how their CI/CD deployments work, what are the credentials in the database, what are the internal way of them automating internal processes inside of that company, database credentials. So I would say Jenkins is probably the worst.
Okay, thank you.
Quick question. So you mentioned that you stopped when you realized that you have like a governmental IP and some governmental data in there. So with regards, considering that you have the Trickest platform, the question is what would happen if someone would do the same, let's say, search against governmental IPs, but they wouldn't stop and they would do, like more aggressive scans?
Yeah, it's connected to our legal and terms of service. So basically, we are not taking a responsibility for the user's actions. So we basically give you a machine gun, but where you point it, it's not our part of the puzzle. So basically, we are obliged to, if that happens, to provide information, of course, to any authorities or a police or anyone who would ask that. And additionally, we would have a self-hosted solution where people could attach their own stuff, their own machines. So IPs that are attacking and the accounts where those IPs are theirs. So we are not connected to it. We are not managing it.
Thank you for the presentation. It was really nice. I just wanted to ask, how did you obtain authenticated access to Jenkins?
Just by opening the IP and the port. It doesn't have any logins because of misconfiguration.
Ah, okay. Okay, then.
Thank you for the presentation. My question is, do you have a report published about your findings?
No, but I think presentation will be public, right? I can actually do one. That's a good idea. I can do one and then send it like publicly to all of the people.
Okay, thank you.
We saw that you are making like a workflows for kind of automation things, and is it possible to make some kind of automation for attack surface monitoring? Because you told us that you have like you can scale a lot of things and machines, so maybe for some huge infrastructures it could be interesting to have.
Yeah. Actually, like we integrate the open source tooling, and like just like the way these workflows are built for scanning the IP ranges, the targets, the inputs could be domain names, subdomains, and then automate the whole attack surface monitoring process inside of our workflow.
Yeah, and is it like for only external infra, or you can do it for internal things?
It's for the external, but with the self-hosted machines, it will be for the internal scanning as well.
Okay, thank you.